Number 6 Operating Systems Lab, classic problems of synchronizations using semaphores. So the first question is the producer consumer problem. So I'm going to write the code. I've written the code in Python. So for this question, first I've declared three global variables: mutex, empty, and full. So mutex will act as a flag. So and I've declared two functions, wait and signal. In the wait function, first after we pass the variable flag, it checks if it's either empty, mutex, or full, and if it's either of them, we're going to reduce its value by 1. And we're going to do the exact opposite for signal. So if it's either mutex, empty, mutex, or full, we're going to increase its value by 1. So in the main function, we get the buffer size from the user, and we declare a list named buffer, and we're going to initialize the flag, initialize mutex as 1 and empty as the size of the buffer, and we're going to initialize full as 0. So while true, first we ask the user whether it wants to produce, consume, or exit. So we get the choice from the user, and we check if the choice is equal to the first option, that is produce. So by default, if mutex is 1 and the empty is not equal to 0, that it has some value in it, we're going to ask the user to enter the value, and we're going to pass empty and mutex into the wait. So we're going to reduce it by 1, and we're going to append the value given by the user into the list buffer, and then we're going to pass mutex in full through to the function signal, so it will increase its value by 1. Else we're going to say that the buffer is full because it's not empty. And if the user chooses the second choice, that is and first we have to check if the buffer is empty, that is if it's greater than 0 and the mutex is 1. Then we pass full and mutex to the wait function, that is reduce it by 1, and then we print the consumed value is we get the last item of the list through pop, and by reducing the length -1, because it will be we have a null value. So we pop the last element of the buffer, and we pass mutex and empty to the function signal, so it increases by -1. Else we're going to print that the buffer is empty because it is less than 0. And if choice is 3, we come out of the loop. So we can run this. So I'll enter the buffer size as 5, and first I'll produce a few elements. 3, produce 8. Then when I go to consume, I have to get 8. So I will get 8, and then if I consume again, I'll get 3. And then exit. So the next question is readers and writers. So for this function, for this program, I've imported shuffle and choice from the random library, and I've declared temporary variables mutex, empty, full, the reader index, writer index, count, and write. So similar to the previous question, I would declare the function write and signal. So for empty, mutex, full, and wrt, if that's the value that is passed, we're going to reduce it by 1, and in signal, if it's empty, mutex, or full, we increase it by 1. So in the readers function, we first declare the read count as 0, and we're going to pass mutex to the wait function, and then we increase the read as increment the read count, and if read count is equal to 1, that is the default value because we are going to increment in the function, then we pass write in the wait function and mutex in the signal function, and then we declare global variables count and r index, and then we print the the position of the index, and the reader count as the string of count, and we increment the r index by 1, and if the read count is 0, we pass wrt in signal and mutex to increase it by 1. So in the writers function, we pass writers in the wait function, and we declare the global variables count and w index, and we multiply the the given value. So the value will be count is equal to count into 2, and when we print the writer and the position and modify it to the given count value. And then we increment the w index and the signal, and we pass wrt in the signal, so it increases by 1. And in the main function, first we declare all the values mutex, wrt, count, r index, w index as 1, and we say the read count equal to 0. And then this is the function that we are calling. So we're going to declare temporary variable. We put readers and writers in the list. So for I in range of 15, random variable, we're going to randomly choose between the reader. We're going to choose between the reader and writer function, and then we'll get the output. So as you can see, we randomly get 15 outputs, and we are going to randomly modify the count to the given values. So the next question is the philosopher question. So for this one, first I'm going to import choice from the library random, and I've declared a global variable a. I've defined weight, and after we pass the processor number, we declare a global variable a. I'm going to put that as a list and declare it as and reduce the value by 1. And for similarly for signal, we're going to increase the value as 1. So in the main function, we have declared 5 values according to the question. So declare 5 variables representing 5 philosophers. So while the function is true, first we initialize I is equal, and we are going to pass this as a process number. So 0, 1, 2, so the 5 values is a process number. So first we are going to copy the whole list in the copy 1 and copy 2. We're going to copy the list, and we're going to say that p is equal to we're going to take the choice from the user. So either 1 can eat at a time or 2 can eat it at a time, and exit. So if the user chooses 1 at a time, we're gonna allow one philosopher to eat at a time. So while I is less than 5, because we have 5 philosophers. So we first with the random philosopher, we're going to get a choice. We're going to use the function choice, so we can randomly choose any number from 0 to 4, and then we pass that to weight, and we do a +1 because it's 0 to 4, and we are divided by 5. We take the remainder of 5, and then we print that first we print the philosopher p and the random number that we get. So for example, if I choose 1, I will get the number 2 because you have 0. Then is granted to eat, and we add 1 to it to get the next one, and we subtract 1 from it to get the previous one. So we get those two that will be eating. That is the two philosophers on the right and left of the philosopher that is granted to eat. And then we pass the number to signal, and then we increment the signal value modulus 5, and then we remove that number because they already got a chance to eat, and then we increment it by 1, and if length of process, and if it's 0, we come out of so it will repeat until we get the number 0, and will come out of the loop. Else, if the user chooses to allow two philosophers to eat at the same time, we call two variables c and j, and initialize it as 0. So while j is less than 5, because we have maximum number of 5 philosophers, we randomly choose one from copy, which was already the number of the numbers, and then we pass it through weight, and then we put the next one, modulus 5 in weight again, and then we take the random philosopher that we got, and the one after it, that is the next one, and the next one, and then we are granted to eat, and the one adjacent to those two. So the one the third position from the one that is granted to it, from the fourth position and the first position, that is the three philosophers that come in between the two philosophers that are granted to it. and then we pass then we pass it to signal, and we pass one after that the signal model is fine, and we remove the ones that are granted to it, and then we increment j value, and if length of this, and after since we are incrementing them one by one, after we're removing them one by one, we at a point after all the philosophers get a chance to eat, the length will come down to 0, and then we can come out of the loop. So we can run this. So first we'll try one at a time. So first we get P4 is granted to each, so the one will be the one before that P0 and adjacent to it. Since the loop is from 0 to 4, so the one left and right are waiting. If P1 is granted to you, the one left to it will be 0 and one right to it will be P2. They are waiting. If it's P3, the one left to it is P2 and one right to it is P4. Similarly for P2 and P0. So if you put 2 to it at the time. So first we get if P1 and P3 are granted to eat, the one in between P2 is waiting, P0, the one left to P1 and the one right to P3 is waiting, that is P4. Similarly for P3 and P0, P0, P2, 4 and 1, 2 and 4. Thank you.